My name is Kellen. Welcome to the course. We are going to discuss some essential combining logical operators in set theoretic methods, such as QCA. It is worth to mention that in set theoretic method QCA, there are three logical operators, and usually with the star symbol. The OR operator, usually with the plus sign, and the NOT operator, usually we use with the tilde sign. Those operators very often used in set theoretic methods, and they are connected together using 5 rules, namely commutativity, associativity, distributivity, the excluded middle, and the Morgan's law. First, the commutativity rule. This rule means the order in which two or more elements are connected through the AND operator or the OR operator is irrelevant. We have example, A and B is equivalent to B and A. Likewise, A or B is equivalent to B or A. The second rule, associativity. With the same operators, the sequence in which single elements are combined isn't important. If we first create a conjunction of A and B and then combine the result with C, or if we first create a conjunction of B and C and then combine that with the condition A, then the two results of these expressions are the same. And this rule holds for disjunction expression with the logical OR as well. The third rule, distributivity. When AND operator or OR operator are used in the same logical expression, elements which are shared by the various elements can be factored out. We have example. We create the union set or the logical OR between the two conjunctions A and B and A and C. As we see, A is a common factor between AB and AC that can be factored out. Let's move on to the rule of the excluded middle. If we create a union of a set with its negation, the universal set will result. And this is the example. The set A plus the set negated A. We have the universal set. This means all members in the set and all members are not in the set are combined together, creating the universal set. If we intersect a set with its negation, then the empty set will result. This pattern means an element cannot be at the same time a member of a set and of the negated set, which is known as the rule of the excluded middle. This rule is not applied to fuzzy set in which a case can have the partial membership in both the focal set and its negated set. However, in fuzzy set, it is impossible for the same case can be more in than out of both a set and its negation. We had the last rule, the Morgan's law. This rule states, if a statement is negated, the present elements become absent elements and vice versa. The logical operator or the plus sign becomes an operator, the star sign, and vice versa. This is our example, applying the Morgan's law rule. The negation of this expression, such as A or B, become the negated A and the negated B. Now let's use an example to understand more the rules. We have the membership score in three single conditions, A, B, and C. We need to calculate the membership for the example case. In the complex expression, that is the disjunction of A and the negated set of disjunction of B and C. We first start with the negated set of disjunction of B and C. Apply the Morgan's law. The expression will be rewritten as A combines with the conjunction of negated B and negated C. In the conjunction and operator between negated B and negative C, we take the minimum value between negative B and negative C. We already have the original score of B and C, then just simply subtract those courses from 1 and we will get the negated scores, which is 0.1 and 0.9, respectively. The minimum value between 0.1 and 0.9 is 0.1. So the score of the conjunction of negative B and negative C is 0.1. The final OR expression requires taking the maximum value of this 0.1 and the value of A, 0.8. Then finally, we have the membership score of the focal case in the complex expression is 0.8. It's time for us to wrap up what has been discussed. No matter how complex logical expressions are, the membership of each case boils down to one number. If we know the set membership scores in the single conditions, we can calculate the membership of each case in the complex expressions using three main logical operators, and, or, not, and relevant rules such as commutativity, associativity, distributivity, and the Morgan's law. I hope the course is useful for you. There are more relevant topics in this course. Let's learn more and see how you can apply set theoretic methods such as QCA in your profession and the social science research. Thank you.